Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be we're going to continue talking about the Cartesian plane, and we're going to talk specifically today about what's called intercepts. An intercept can best be defined as when a line crosses the axes. Either axis, the x-axis or the y-axis. I've got it written down here. You can look at it. Intercept, where the line crosses the axes. Now, what does that mean? Well, if you want to look, you can look in your book. We are on page number 98. If you want to keep up with us there in the book, we're on lesson 3.2, intercepts. So what does that mean? If you look in the book there, they've got a little picture of a Cartesian plane. I kind of wrote here on the screen just a kind of an X and a Y axis. I don't have the little marks here. But if I take a line and I put a line on that Cartesian plane, and the line can go anywhere, okay? And I want you to see something. Unless it's straight, okay? So like what's called parallel or perpendicular, unless it's straight in one of these two ways, it will cross both the x and the y axes. So look, if it's here, it will cross it at some point. Okay, if it's here, if it's straight, it won't. If it's here, if it's parallel to the x or perpendicular to the y, it will only cross one. But everywhere else, it will cross it at some point. Remember, these go indefinitely in all directions, so they go forever in all ways. Okay? All right, so we'll just go right there. Now, if you look, what I've created when I do that is I've created 2 points. One of the points is right here, and one of the points is right here. These are called the intercepts. The intercepts. Now, this would be the x-intercept, and so the x, I call it like this, x-int, x-intercept, is what? Let's say it's 1, 2, let me do that a little bit better. 1, 2, 3, 4, okay? So the intercept for the x would be 4. In other words, it crosses the x line at 4. The y-intercept would be where? 1, 2, 3. Let's call that 3. So the y-intercept would be at 3. Okay? And so that's where it crosses the x line and where it crosses the y line. Well, what happened if it crosses down? If it crosses down here somewhere, then it'd be negative. What happens if it crosses over here on the left side? Well, then it would be negative on the x. So depending on where it crosses the line, it could be positive or negative. But every line, except for, like I said, perpendicular, parallel, which are straight lines, okay, straight to the axes, they would never cross. But any other line always crosses somewhere, crosses both lines somewhere. And so every line, except for perpendicular and parallel, which we'll get to in a later lesson, will have these. They're called intercepts, the y-intercept and the x-intercept. Maybe you can think of this as a road in your neighborhood. Well, the roads cross each other. At a certain point, they cross each other. Now, if those roads are straight, if they keep going straight, how many times do they cross? Only one time. So, in other words, this can only cross the x line one time. It can't, if this line keeps going, it can't make a curve or anything like that. It's a line, it's straight. So it's going straight. So it can only touch the x line once, and it can only touch the y line once. These are what's called intercepts. There's only one of each. Now, you could have multiple x-intercepts if you had like some kind of a different shape. Like if I had a U shape, then it could touch the line twice. Okay, and that's a thing. That's called a parabola. We'll get to that. This is called a wave. So if it's a wave, it could be touching the x line multiple times. This one touches 1, 2, 3, 4 times. And if we keep going, it would keep touching it. Okay. And so there's different types of shapes that we can put on the Cartesian plane. But for right now, the equations that we're doing, what we're using, they're called line equations, and so they form a straight line. And in these cases, they can only touch the x-intercept once and the y-intercept once, okay? So for this line that I just drew randomly on the screen, its x-intercept is 4 and its y-intercept is 3, okay? If you look down there in the book on the bottom of page 98, you will see where it shows the x and the y-intercept, and then it kind of shows a little bit about it. One thing that it shows before it kind of tells you how to solve it, which we're going to get to in a minute, is it tells you about this, standard form. Standard form. It's right there in the very bottom of page 98. Now, standard form is the standard way, or the best way, you could say, to write these if you're looking for the intercepts. Okay, it's called standard form. You need to know that. You need to memorize this right here. Okay, that's important. Now, there's some rules for the standard form, and here's the rules. There's 3 rules. Number 1, A, B, and C, these right here, A, B, and C, they must be numbers. They must be numbers. A, B, and C are numbers. You say, wait a second. No, it's A, B, and C. But in the real equation, when you actually have an equation, A, B, and C will all be numbers. Okay, so that's the first rule. Number 2, A and B both cannot equal 0. Now, one of them could equal 0, but they can't both equal 0. Okay, only one of them or none of them. If both A and B equal 0, then it is not a line equation. Okay, you don't have a line equation. Let's see, and then number 3, the last one, is A must be positive. And this is A like as in the letter A, not must be positive, but A, the letter A. This one right here must be positive. So you can't have a negative out front. So this would not be standard form with that negative sign. We have to get rid of that negative sign. And we'll talk about how to get rid of that negative sign. But basically, you can't have a negative sign out front there. Okay, so those are the 3 rules about standard position. A, B, and C have to be numbers. A and B both cannot equal 0. And A must be positive. Okay? All right. And so there is your standard form. Make sure you kind of understand that. And we'll work with it just a little bit more. But standard form, this is kind of how you want it to be set up when you're looking for the intercepts. All right. Go ahead and turn in your book to page number 99. Page number 99. Let's go ahead and try one of these. Let's see what we can do. There is a statement on, well, I think I might have gone too far. There's a statement on, yeah, there it is, page 98. So go back there if you will. And it says, since the y coordinate is 0 along the x-axis and the x-intercept must be of the form x, 0. What does that mean? Well, here's what it means. If you will, to solve these, if you will plug a 0 in for the other letter, you'll get the solution. You'll get the intercept. What does that mean? Well, let's go back to page 99 now. And let's look at this one. So here is a problem. X plus 3, y equals 6. Now, is that in standard form? That's our first question that we need to ask ourselves. Well, look at standard form right here. AX plus BY equals C. So, okay, so what is standard form? Standard form is AX plus BY equals C. And what are the rules? A, B, and C are numbers. And so let's look at this. Well, C is a number, and B is a number, but the A is not a number. A is nothing. No, that's not true. A is a number. What is the number always in front of an X? Always in front of a variable. The number is always 1. Okay, so A is a number. A is the number 1. Okay, and so, all right, well, that sounds good. Well, they're all numbers. What's the second rule? A and B both cannot equal 0. All right, A is 1 and B is 3. Okay, good. and then A must be positive. Okay, it's a positive one, or there's no negative sign, so that must mean that it's positive. So, all right, looks like we're good. So we have it now in standard form. So that's where we want to be. And now what we want to do is, here's kind of the trick. Here's the thing. If you are looking for the y-intercept, then here's what you're going to do. You're going to put, we're going to put 0 in for x. Okay, so we're looking for the y-intercept. And so we want to put 0 in for x. What does that mean? Well, watch. We just do algebra right here. We put 0 in for the x. So let's try it. 0 plus 3y equals 6. Or this, we can just get rid of that. Divide both sides by 3, and we get y equals 6 divided by 3 is 2. So y equals 2. So our y-intercept is 2. Okay, so in this case, our y-intercept equals 2. Okay. Now, how do we get the x-intercept? All right, so the x-intercept, what do you think? I mean, right? Come on. You put 0 in for y. That's right. So if you get the x-intercept, or if you get the y-intercept by putting 0 in for x, then you get the x-intercept by putting 0 in for y. Okay, you just kind of switch it around there. So let's go ahead and go back here and let's erase all this. And let's substitute that in now for 0 in instead of y. X plus 3 times 0 equals 6. What is 3 times 0? 0. So x plus 0. We don't even need to write that because it's nothing. So x equals 6. Okay, so the x-intercept equals 6. Okay, so there we go. We have the y-intercept is 2, and the x-intercept is 6. All right, so now what we do is we have the two intercepts, and now what we're going to do is I'm going to go down to the graph, and I'm going to put the graph paper on here in just a second. Okay, so here we have the graph, and I wrote over here on the side that the y-intercept is 6 and the x-intercept is 2. So what we want to do is we want to come over here. I'll put it in this pink color, and we'll come over here and we're going to put a point on this right here, the y-intercept. Which line is the y? Well, this one is, the one that goes up and down. Okay. And so on the up and down line, we're going to count to 6. I think I got 6 on here. So 1, 2, 3, 4, 5, 6. Yep, all the way at the top. Okay. And so that is where the line is going to cross our y. That's our y-intercept. Now, our x line is this line down here. And where does it cross the x line? Well, it crosses it at 2. So we're going to come over here, 1, 2, and we're going to put a point here on the 2. And so that's our x-intercept. And now what I would do, and this is the cool thing, you can graph, all you need is two points, and you can go ahead and graph that. And I'm just going to go ahead and draw my line through both of those points. Okay, and so this would be our line for this one. This would be in between the points 6 on the intercept. And how would we write this? You could write this right here. You write the intercept, write the intercept like this. 0 on the x, 6 on the y. So that's this one. And then for the x, this one over here, well, this one down here, is going to be 2 on the x, 0 on the y, because we substituted in 0 to give us that. So that's where those come from. The 2, 0 would be the 2 on the x and the 0 on the y. And that's going to tell us whether to go up and down, that's the y, or whether to go left and right, and that's the x. So on this one right here, we're going to go over 2, 1, 2, and up or down, 0. So there it is right there. And then on this one, the 0, 6, we're going to go left and right 0, and we're going to go up 6. And so there's those 2 points. Okay, and then you draw the line through them, and then you're done graphing it. So this is like a shortcut to graphing. This is like, the other day when we did all those charts and things, you can do it that way, but maybe an easier way for you to do it is to graph using the X and the Y intercepts. All right, that's all that I have for you. If you missed something, you can go back and rewind it, try to watch it again. You can always message me, leave something there in the comments, and I can try to help you out with it, okay? All right, we'll see you later. Have a good one. Bye-bye.